My name is Karl Mattson. I'm the Chief Information Security Officer for Endor Labs, software security company. It's a big privilege for me to be here today. And first of all, thank you all for taking the time to join. Your time is very valuable. And for me, this is special because the Cloud Security Alliance has been really in my career for the last decade as a CISO at a financial institution, both at a bank, later at a mortgage company, and now here as a sponsor. It's really a privilege to share this presentation with you today. So first of all, by background, I have the financial services in my pedigree, but now moving on to the security vendor side, it really gives me a chance to focus on the future, looking about what we can do as a security technology community to enable financial services to move forward and capitalize on innovation and modernize as we go forward, but meanwhile doing so in the spirit of responsibility, compliance, and trustworthiness that we need in the financial services institutions. So without further ado, let's talk today about securing the software development revolution. I imagine this isn't news to most of you joining today, that software is under attack. There has been a continued spike in the number of software vulnerabilities that continue to be discovered and exploited across our field. Every year, this is a substantial increase in exploitable vulnerabilities. And that march is nothing but continuing on as we go forward. What's also true is that the software development world is capitalizing on AI augmentation. That can be measured both in the AI-generated source code. Google, of course, reporting about 25% of its code today being generated by AI. The second attribute really is efficiency. So Goldman Sachs reporting so far about a 20% efficiency achieved by utilizing AI copiloting for software development. And then the state of open source LLMs. So, it's common to think about what we see in the maybe the public news cycle focusing on OpenAI and Azure AI and Anthropic and organizations that are putting together private models that are really remarkable. However, open source LLMs, the spike in use of open source LLMs is really striking, not only because of their utilization. Obviously they're free and they're customizable, but 50,000 organizations using open source LLMs as part of their application development. So for those of you who may be not familiar with Hugging Face, it's essentially an open source library, not unlike a Git repository for open source LLMs. So what we think of in terms of Endor Labs certainly is that the Google, OpenAI, Anthropic, Microsoft organizations of the world, they do have really some of the most sophisticated technologies and sophisticated security teams in the world working on protecting and securing those models. In the open source world, though, it's a wild west, and that's why we put a lot of focus on open source models, specifically because they're unprotected in a lot of cases. So this open source space, we think, is the most likely place to bite organizations because of the lack of controls related to open source models. That, frankly, I think we can look at some of the bigger flagship private models as pretty well constructed when it comes to basic security controls. So let's talk about the current state of application security. IDC evaluated over 1,000 organizations and found that on average, developers are spending 10 hours a week researching, remediating security vulnerabilities. 10 hours a week is about a fourth of a developer's time, which averages out to about $28,000 of annual productivity tax on software developers. And what's even striking about this more so is that the problem is getting worse, according to developers. They're seeing security requirements put a greater and greater tax on their productivity efforts going forward. Now, if we look at the history of CVEs being published in the wild, if we don't change application security practices, we would only see this sort of productivity tax increase. More vulnerabilities would then require more developer time to remediate. The current state of application security is falling behind. We are finding that organizations are unable to deal with the noise and the volume of vulnerabilities that application security teams are coming up with, and they're starting to tune out. And so we lose traction when we lose credibility with our development teams. So meanwhile, there's emerging trends, of course, across the globe right now that I think are going to be driving where software development goes in the future. And so if you bear with me for a minute, let's start at the top level of where things are going strategically. Just this last month, the United States announcing $500 billion in AI infrastructure, as well as the EU countering, both France and the EU committing over $100 billion of their own AI infrastructure. Now, when you add that to the AI infrastructure investments that are being made by Google, Meta, Oracle, OpenAI, NVIDIA, et cetera, we're talking about well in excess of $1 trillion plus forecasted for direct investment in AI infrastructure. The ongoing investment in AI will become more pressurized to develop and deliver applications quickly that deliver value. Even if one is a bit of a skeptic in the impact of AI, it is undeniable that when trillions of dollars are spent on infrastructure, there will be expectations of delivery. Those expectations will continue to rise, and pressure will build to deliver or applications. So I'll give you a minute to read this for this moment, this Dr. Strange meme. So what I'm going to start with now is really the first sort of concept that I'd like to lay out, which is this concept that is a not imperfect analogy, but we call it the SDLC multiverse. So bear with me for a second, because what this does is it leads us to thinking about how to structure application security in a complex, high-pressure world. So what is the SDLC multiverse? Well, it's a future state where all software development realities are present simultaneously. Well, let's break that down. What does that mean? It means everyone is a software developer. Each employee would have the ability in the future to, in at least a limited sense, generate their own source code, their own models that perhaps they run locally. Employees running, for example, applications that might do something like optimize their calendar. Employees can now generate code. The second is every methodology in use. So for example, an organization may still have a mainframe. An organization also has legacy applications, also has cloud-native applications, also has digital products, also has sort of citizen-developed applications. What this creates is it creates a future state in which any organization of size is going to sort of necessarily have multiple software delivery methodologies all active at the same time for good reason. The third is every design paradigm is in play. By design paradigm, we'll go into this a little bit more, but what I mean by that is emerging paradigms like the creation of platform engineering teams, which is relatively recent, but is showing a lot of promise in terms of its results and effectiveness, or secure by design, secure by default, shift left, DevSecOps. That's sort of a salad of industry buzzwords, but each of those concepts is really founded in some security principles that are advisable, and so organizations to some degree have created practical processes around these paradigms to raise the assurance level of software. The fourth is development and production activities essentially being concurrent. A lot of organizations, of course, have already moved to continuous deployment, continuous delivery models, but that is still not the majority of applications in the majority of companies. It still is a relatively sort of niche number of companies and organizations that truly are delivering software continuously. But as we move forward, as we think back now to the kind of delivery pressure and speed pressure that the AI investment is going to ask of us, what we can expect to see is a continued march towards continuous delivery. The second from the end, team and organizational design being ephemeral. So this is kind of related to the last one, which is control gates. So imagine, from time in the past, what we would do as an organization was organize our teams sort of around the methodology of a SDLC. So for example, a developer at a certain point in time checking in code, perhaps going through a peer review, and then after peer review moving on perhaps to a quality control team or a QA/QC function. And then after a QA/QC function, perhaps there's a security test that happens. So what we can see teams organizing around control points or around sequences of an SDLC practice. However, if we're looking at things like a citizen developer plus a waterfall methodology plus a SecDevOps methodology in one part of the organization and other software elements that have a platform engineering team, what we can see is our control points kind of fall apart because we sort of have to be in all places at all times. And then that creates a question is like, well, how do we organize around that? Do we organize our teams the same way? So what I suggest here is that team structures and control gates will be ephemeral and flexible as we go forward. So what is new in software development? AI-generated code obviously is going to keep marching towards the norm. So how does this play out? How does this play out for the security organization to establish an application security program that can weather this kind of complexity, this kind of demand, this kind of pressure? Well, we think that there are really 6 principles. There's 6 principles that the application security of the future program can be built on. And those 6 principles essentially remain consistent regardless of the SDLC methodology, and regardless of the paradigm of shift left, DevSecOps, secure by design, and regardless of whether it's citizen developer or whether it's a highly centralized group or business line development. So keeping in mind these sort of 6 principles, and may not apply in all circumstances, but what we want to achieve is we want to achieve an application security team function, which is that it is the function necessary for proper build, ship of trustworthy software under all weather conditions. Particularly in financial services, we have to be able to apply AppSec principles across our universe of software. So first, accuracy. Until we have accuracy in our findings, sort of everything's a moot point. We have to provide developers detailed reachability as to whether the vulnerable is exploitable, it's reachable, it's fixable. We have to provide the developers better data, better vulns. And we have to provide them with a significant degree of what we call like decision support. So that's the second area, self-service. We have to equip developers, platform teams, application security, whomever is looking at that finding, whoever is the resolver of that finding, needs to be supported with information that helps them make decisions. For example, if I provide a vulnerability, I need to provide exactly which lines of code are affected. Here's your first-party code snippet, here's your function and third-party code, here is precisely where that vulnerability is at, and what would be the impact of upgrade option A, B, and C. When the developer, the platform engineering team, the DevOps team can look at a vulnerability and say like, oh, that upgrade option is low impact. Like they can wrap their arms around that and achieve it quickly because they have all the information they need, they have all the specificity, and what allows them to do is self-service. You know, I think many of us might remember the days of old when we would sit down with an application team every 2 weeks, every 4 weeks, and review vulnerabilities. That model has to be dead. It has to be dead. It has to be allowed that the resolver teams can self-service the process of decisioning and remediating. Third area I'd put is integrated. We have to be able to, of course, also pinpoint when a new vulnerability is announced, where exactly in production is that asset running today. We have to have artifact signing. We have to have integration with our production runtime environments. The big asterisk on this one, though, is if you connect production assets to vulnerabilities on the application side on the left, if those vulnerabilities are noise and false positives, you'll create chaos. So what we need to do is we need to solve the accuracy and reachability problem first, then integrate with our production so that when a new vulnerability is announced and we look, hey, how many assets are running log4j today? We have a precise answer for that, and we know that it's true. The fourth area I call it headless. And what this really means is that security technologies need to be looked at by the developers as running under the hood of the developers' tools. We don't need to have the developers go to the security tool. What we need to do is we need the security information baked into the IDEs, baked into the pipeline, the repo, the GitHub environments, so that developers don't have to leave context. They stay in the context they're in, and they can interact with the security information, not even caring about the security tool. And that's the best outcome. Fix-oriented. We have to give options for fixing the easy stuff quickly. Automated PRs. If we know that we can publish We can knock out 80% of our vulnerabilities with low impact, like basically impact-free changes. Knock them out. We've got to make sure that we enable that speed of fix it for the things that are easy, reserving our human time, our human capital, just for those circumstances where judgment needs to be made. And then the last one is LLM ready. We have to set a baseline as an organization to be responsive to LLM risk management. If I asked you right now as a thought exercise, in your organization, do you have a definitive, let's say, regulator-proof inventory of where your in-house applications are using LLMs? Which LLMs? What are open source, which are private source? What is the risk assessment of those LLMs? What is the data classification of data they're handling? Those are the kinds of questions that we need to be ready to solve for or answer to. In financial services, you have to be able to demonstrate this. Now, there's a different universe of use, which is the end user using, like public OpenAI and ChatGPT, things like that. This is about your code. Do you have models in your code? And that's really where we need to have a capacity to answer those questions and be responsible for the software we're publishing. When we accomplish those principles, what we can achieve is we can achieve noise reduction, a substantial decrease in the amount of noise that we're sending to developer teams. We can enable decision support so that regardless of which organizational structure you have, if it's a developer, a DevOps team, a platform engineering team, fill in the blank, how the teams are organized, resolvers and people who are tasked then to remediate have supporting information, the details they need to solve that problem quickly or the impact quickly. Impact-free patching. We have to be able to deploy automation and supporting legacy packages, simple, easy, reserving human time for developer time for just those very small subset of vulnerabilities where we may actually have to change an application to upgrade it. Those should be few and far between. So pursuing impact-free patching and focusing on the fix. The last is LLM risk management, getting that right. These are the achievements. When we focus on those 6 pillars, we can achieve these things. And back to this concept of the SDLC multiverse, when we can create success in those areas, things like a headless implementation of a security technology under the hood of a development repo, for example. When we can achieve those things, what we then become durable to is we can withstand the change of methodology. We can withstand the expectation of speed and delivery pressure that our developers are facing now and are only going to continue to face in the future. So overall, we think that these are principled approaches that you can take to sort of modernize and be ready for the software revolution sort of as it unfolds. And so as the last thing, just in case there's folks that are joining today who I've worked with in the past and who I know that as a leader of application security organizations, I've been imperfect. So I want to share this last thing, which is this is my apology. I think that finally the technology is here, the methodologies are here to be an AppSec program that is a distinct asset to developers, a welcome contributor at the table, accurate information. Where we were a couple of years ago has not been a great place with too much noise, too much friction, too many barriers, too much of standing in the way of delivering value. And I think we're now to a point where there is technology. We'd love to show you what we can do, but there's technology and process and thinking about how to be an AppSec team that's prepared for the future. Great. Thank you so much for your time, and I'll turn it back over to the group.